Our objectives for today's lesson are to be able to identify limiting and excess reactants in a reaction, to be able to determine the maximum amount of product that can be made based on the limiting reactant, and to be able to determine the percent yield of a reaction. So in a reaction, we have two main types of reactants. We have the first one, which is called the limiting reactant. This is the reactant that determines the amount of product that can be formed. In other words, it's the reactant that you run out of first, or the one that you don't have enough of to complete all of your products. The other reactants are what we call excess reactants. Those are the ones that we have plenty of or that we are not going to completely use. So we can use the limiting reactant to determine the amount of product that is going to be made. Let's take a look at a simple everyday example before we move into the more chemistry examples. So you're given parts to build a bicycle in the following amounts. How many bicycles can we make? So the easiest way for us to determine this is to figure out how many bicycles we can make from each set of parts and then find the smallest amount. So our first one we have is 42 wheels. We know that each bicycle has 2 wheels, so that means that we can make 21 bicycles from our wheels. The next one we have is 51 seats. Each bicycle only has 1 seat, so from that we can make 51 bicycles. Then we have 34 frames. Each bicycle only has 1 frame, which means we can make 34 bicycles from the frames. We have 65 pedals. Each bicycle contains 2 pedals, so we can make a maximum of 32 from the pedals because we can't really have half a bicycle. And then finally, from the handlebars, each bicycle only has 1 pair of handlebars, so you're going to get 38 bicycles from the handlebars. So looking at our numbers, we see that 21 is the lowest amount, so we can only make 21 bicycles because we are limited by the amount of wheels. The wheels would be what we would consider the limiting reactant, and everything else would be excess reactants. Now, when we're looking at this in terms of chemistry, there's a couple things we want to do to figure out what the limiting reactant is. When you have a limiting reactant problem, you're more than likely going to have more than one given in your question. So you want to do a stoichiometry calculation for each of those givens, and then whichever reactant gives you the smallest amount, just like we did with the bicycles, that's going to be the limiting reactant. Let's take a look at an example. So this one says, what is the limiting reactant when 80 grams of copper reacts with 25 grams of sulfur, and what mass of copper 1 sulfide would be produced? So just like we've done with all of our other stoichiometry problems, we want to pick out our givens and goals. So in this case, I have 2 givens. I have the 80 grams of copper, and I have the 25 grams of sulfur. My goal this time is to figure out the mass of the copper 1 sulfide. Remember, when it's talking about mass, it really wants grams. Okay, so in order to figure out which one is the limiting reactant, and therefore it's going to tell us the maximum amount that we can make, we need to do a stoichiometry problem with both givens. So I'm going to start with the 80 grams of copper, and I'm going to convert those 80 grams of copper into the grams of copper 1 sulfide. Okay, so going back to our steps for stoichiometry, the first step is to always balance the equation, which we see up there at the top. Looks like it's already been balanced for us. We don't have to do that. Step 2 is to convert our given to moles. So we have grams of copper. In order to convert that to moles, we're going to use the molar mass of copper, which is 63.54 grams, and that's going to be equal to 1 mole. Okay, then now we have moles of copper, so now we're going to move on to step 3, that most important step, which is our mole ratio. So if we go back to our equation, our given substance is copper, our goal substance is copper 1 sulfide. So we see that for every 2 moles of copper, I'm going to create 1 mole of copper 1 sulfide. So plugging that in, we put the 2 moles of copper on the bottom, the 1 mole of copper 1 sulfide on the top. That way my moles of copper cancel. Now I have moles of copper 1 sulfide, but my question asks for grams, so we're going to use the molar mass of that. So 2 times the mass of copper plus 1 times the mass of sulfur is going to be 159.14 grams of copper 1 sulfide. So multiply across the top, multiply across the bottom, and divide. And so from that, we can make about 100 grams of copper 1 sulfide. Now we're going to do the same thing, except for this time we're going to start with the 25 grams of sulfur as our given. So again, we need to convert the given to moles. So we're going to use the 32.06 grams of sulfur, which is the molar mass of sulfur, to get 1 mole. Now we're going to use our mole ratio again. So this time we're using sulfur. So our given substance is sulfur. Our goal substance is the copper 1 sulfide. So for every 1 mole of sulfur, I make 1 mole of copper 1 sulfide. So plug that in. My moles of sulfur cancel. And then just like before, we want to use the molar mass of the copper 1 sulfide to convert to grams. So we see that we could make 124 grams from the sulfur. So since the copper made a smaller amount of product, that's going to be our limiting reactant, and therefore we can only make 100 grams of copper 1 sulfide. Percent yield, this is a concept that tells us the percentage of product that's actually being produced compared to what we expected to produce. So for instance, if we are doing a reaction and we do the stoichiometry and it tells us we should make 10 grams of our product, but when we actually do the reaction, we only make 5 grams of product, then we would have a 50% yield. So it would only make half of what we thought. So the formula for this is actual, which is what you make in the experiment, divided by theoretical, which is going to come from the stoichiometry, times 100, and then your percent is your unit. Let's take a look at an example here. So this one says, what is the percent yield of the product if 97.3 grams of copper 1 sulfide was actually produced when 80 grams of copper and 25 grams of sulfur were reacted? So this is kind of an extension of the last example that we did. It's got the same amounts. So the first thing you want to do when you are finding your percent yield is figure out what is your theoretical. And that's going to come from your limiting reactant. So we already found the limiting reactant, and therefore the amount of product that we can make from this, which was the 100 grams of copper 1 sulfide. So we're going to plug that in on the bottom. And then it tells us that 97.3 grams was actually produced, so that's going to go on the top. And then when we multiply by 100, we see that we get a percent yield of 97.3%. Okay, we have one more example. This one's going to be a little bit tougher. So this one says, what is the amount of magnesium oxide that is produced if the reaction has a percent yield of 65.8% when 52.7 grams of magnesium are reacted with excess oxygen? So in this case, we are going to use the percent yield formula to actually determine the amount that will actually be produced. So we're going to find that actual portion on the top. But before we do that, we need to figure out the theoretical portion. And so they told us that we have 52.7 grams of magnesium and an excess of oxygen. So in this case, they're telling us that the magnesium is the limiting reactant. So we don't have to do 2 train tracks this time. We only have to use the one for magnesium. So again, that 52.7 grams of magnesium is going to be our given. And then our goal this time is we need to figure out the amount of magnesium oxide. So we want to figure out how many grams of magnesium oxide can theoretically be formed, and then we'll plug into our percent yield to figure out how much is actually going to be formed. Okay, so looking at our steps, first step is to always balance the equation. Looks like that has been done for us. So then we have our given of 52.7 grams of magnesium. So we need to convert those grams of magnesium into grams of magnesium oxide. So first thing we want to do after balancing the equation is to convert our given to moles. So the molar mass of magnesium is 24.31 grams, and that's equal to 1 mole. Then we use our mole ratio. So our given substance is magnesium. Our goal substance is magnesium oxide. So for every 2 moles of magnesium, I make 2 moles of magnesium oxide. So I'll plug that in. My moles of magnesium cancel. So now I have moles of magnesium oxide. And then we'll use the molar mass to convert that to grams. So 1 times the mass of magnesium plus 1 times the mass of oxygen is 40.31 grams. So theoretically, we should make 87.4 grams of magnesium oxide from that 52.7 grams of magnesium. However, it tells us that this process only has a percent yield of 65.8%. So what we're going to do now is we're going to plug in to our percent yield formula. So I plugged the percent yield in for the percent yield section. We are looking for that actual amount that is going to be formed. Our theoretical amount was what we did with the stoichiometry, so 87.4. And so if I solve this out for x, we see that we're only going to make 57.5 grams of the magnesium oxide instead of the theoretical 87.4.